In this video, I am going to discuss about Perkin condensation or Perkin reaction. The reaction between benzaldehyde and acetic anhydride in presence of acetate anion at 175 degrees centigrade temperature producing trans-cinnamic acid is an example of Perkin condensation. In general, the reaction between an aromatic aldehyde and an acid anhydride in presence of a carboxylate anion at 175 degrees centigrade temperature producing an alpha-beta unsaturated carboxylic acid is called Perkin condensation. Remember, the carboxylate anion which we utilize as base in this reaction must be corresponding to the acid anhydride. Now we have to understand the reaction mechanism of Perkin condensation. At first, acetic anhydride reacts with carboxylate anion which acts as base in this reaction to produce this nucleophile, which in the follow-up step reacts with benzaldehyde to produce this anion, in which both the reactants are loaded. Please note that the product of this reaction is cinnamic acid, which has a double bond. So we have to create a double bond through beta elimination reaction, which requires a hydrogen atom as well as a good leaving group at the beta position. We have hydrogen here in this carbon, but at the beta position, the group is not at all a good leaving group. This group becomes a good leaving group by accepting acyl group, which is marked as green color. The acyl transfer takes place by the reaction between this negative charge with this carbonyl group to produce a six-membered cyclic intermediate, which again reopen from the other side to finalize the acyl transfer process. Please note that in these two intermediate X and Y, the acyl group has been transferred from this oxygen to this oxygen. As soon as the carboxylate is generated, it will immediately react with acetic anhydride to produce anhydride of this compound. At this point, acetate anion will act as a base to trigger beta elimination reaction, producing anhydride of cinnamic acid. At the last step, hydrolysis of this anhydride produces trans-cinnamic acid. In regard to this reaction mechanism, we have to discuss two important issues. The first issue is that the evidence of acyl transfer process from X to Y, and the second issue is that why trans-cinnamic acid has only formed, not the cis one. In order to gather evidence for this acyl transfer process, we have to stop the reaction at this stage. That means we have to stop the follow-up beta elimination process. For that, we can substitute this hydrogen atom with a methyl group. Now, please look at this very closely, that this carbon comes from the anhydride unit. That means we have to modify our anhydride component. So, accordingly, the reaction is designed. We have taken benzaldehyde and the methyl substituted acetic anhydride, and the reaction stops just after the transfer of acyl derivative from this oxygen to this oxygen. Here, as we have treated with acid, the anhydride at this portion has been hydrolyzed to acid in the isolated product. Observation of this product in this specially designed reaction supports the acyl transfer process in the reaction mechanism. Now we have to look at the second issue, that is why trans-cinnamic acid is formed. For that, we have to look at the elimination step. This is the elimination step occurring with this intermediate. Now we have to analyze the conformers of this intermediate with respect to this bond. For this, we will take the help of Newman projection. Let's number these two carbon as number 1 carbon and number 2, and we can plot the Newman projection by this way. This is carbon number 1 and this is carbon number 2. Here I have kept the two eliminating groups, that means hydrogen and the acyl group, in anti position because this is a necessary orientation for a beta elimination process. We can obtain a second conformer just by rotating carbon number 1 by 120 degree in anti-clockwise direction. Now, as you can see, there are three big substitutions are fighting among themselves, whereas in this conformer, only these two big substitutions are fighting among themselves. This means that this conformer is more stable than this conformer. So in solution, this conformer will exist in major amount. So the reaction will proceed with this conformer. Here acetate will come and perform the elimination job. Here, as you can see, these two hydrogen atoms are situated at the opposite side, and this anhydride derivative and phenyl group are situated in opposite direction. Therefore, in the produced alkene, they will also remain in the opposite direction. As these two hydrogens are in the opposite direction, this alkene we will call as trans alkene, and this compound is the anhydride of trans-cinnamic acid. Upon hydrolysis, this anhydride will generate trans-cinnamic acid. This is why trans-cinnamic acid is formed in Perkin condensation. Here are some important points to note in regard to Perkin condensation reaction. The first point is that electron withdrawing groups at the aromatic ring increases the rate of reaction. However, electron donating group retards the process. For example, para-nitrobenzaldehyde undergoes Perkin condensation to yield 82% of para-nitrocinnamic acid. The second point is that the reaction is only applicable to aromatic aldehyde because the aliphatic aldehydes undergoes self-condensation reaction. The third point is that we are using a base in the Perkin condensation. Here, other bases are less satisfactory as they destroy the anhydride. For example, if we are using acetic anhydride and at the same time if we use ethoxide, then this ethoxide will react with acetic anhydride to produce ethyl acetate. That means the anhydride is now destroyed, so the reaction will get hampered. So the question is, what type of base we should use in Perkin condensation? So we should always use carboxylate anion corresponding to the anhydride. For example, if we want to do this reaction, the reaction of benzaldehyde with acetic anhydride to produce tranexamic acid. Here we have to use carboxylate anion which is corresponding to the anhydride. This carboxylate anion will act as base in this reaction. Now let's say by mistake, instead of carboxylate anion you have taken benzyl carboxylate anion. Then what will happen? This benzyl carboxylate will react with acetic anhydride to produce a different anhydride. And now this anhydride will react with benzaldehyde to produce phenyl substituted tranexamic acid. That means you wanted to synthesize tranexamic acid. Instead of this, you will end up with phenyl substituted tranexamic acid.